Hi, we're going to talk about the triangle inequality now. Now you might say, what is the triangle inequality? Well, essentially, it's about defining what isn't a triangle. But you might hear that and think, okay, that's really, really obvious. Anything with more than three sides or less than three sides isn't a triangle. A triangle is a shape with three sides. That's very simple. What could there be more than that? Well, here's the interesting thing. Things like this. This has three sides. These sides are all straight line segments. Nothing weird or funky there. But we can all say that this isn't a triangle. The sides don't all meet. I don't have three vertices. In short, this is clearly not a triangle. But why exactly? What is there precisely that makes this not a triangle? But something I can write out algebraically. Something that I can determine for every single triangle I could think of drawing. What rule fits? That if I didn't have that rule, I couldn't have a triangle. That's where the triangle inequality comes in. And it says, for any triangle I can think of, the sum of any two sides must be greater than the third side. You can think about this way, right? Say, hey, if I have a triangle A, B, C, well then AB plus BC combined have to be greater than AC. If AC is, longer, what do we have? Well, we have a bit of a problem. If AC is longer, we have something funky like this. Now, clearly this isn't a triangle. We have this huge gap sitting out. What is that gap doing here? Who knows? But this is not a triangle. So this is the inequality that we have. I'm going to rewrite it up here. But the real question is, why is it true? Let's prove it. This will be a good chance to exercise our proof skills. So first, I'm going to rewrite this like that. Right? And I'm going to start the triangle like this. I'm going to call it C. And now let's say I want to extend BA to point D. So I essentially form an isosceles triangle. So AD and AC are equal. And of course I'm going to join C to D. So I essentially tacked on another triangle. Now, what does that mean? Well, here's what we know. Because these two triangles are isosceles, that means that these two angles are going to be the same. All right, that makes sense. Well, what does that mean here? Well, we know this angle here, angle BCD, is greater than ACD, right? ACD is just a smaller portion of BCD, which means angle D is going to be smaller than angle BCD because, it's equal to this, which is a smaller proportion. Makes sense. But where are we going? Well, sides opposite larger angles are larger, which means this side BD, which should be a straight line. Imagine this is a straight line, right? Side BD is opposite the larger angle, BCD, right? So that means BD is larger than the side opposite the smaller angle, which is BC. But this doesn't help us get to that. That's clearly not what we want. Well, look at BD. What is BD? Then It's AB plus AD, and that's greater than BC. But that still doesn't really bring us anywhere, because as you might see, we don't have any D's here. But here's where we use this isosceles triangle and we say, well, AD is the same thing as AC, so actually that AD is the same thing as AC. And we have precisely what we wrote up here, down here. And that is our proof. So, not only can we learn a valuable lesson about what is and isn't a triangle through the triangle inequality, we can actually see a valuable lesson in proof making, which is that if you ever asked to prove something pretty difficult, something hard, something you don't know exactly how to do, draw something. Add something to your diagram. Add a new triangle like we did here, and that'll help you out a whole lot. But that's all I have. I hope that was helpful, and I hope you have a great day.